Okay, here's our topic, theoretical and actual yield. And here's some important stuff, some hyperlinks and stuff, and QR codes if you want them. Compare and contrast is what C and C means, and I want you to be able to basically tell me how they're the same and how they're different. And let's say, in a similar fashion, or comparing and contrasting these two characters, I might say something they have in common. They both like hot drinks. One likes tea and the other likes hot coffee with a straw. All right? Now, here are their definitions. The maximum amount of a product that can be made in a chemical reaction based upon a limiting reagent. That's your theoretical yield, whereas actual is the amount of product actually produced by said chemical reaction. All right. Now I want to go over some examples, real life and some chemistry, to highlight their difference is, let's say you're building a fence, and the wood that you get is your theoretical yield, and our yield in this case is to be able to put the wood up on the fence. But with each piece you put up, you have to cut the board. So your actual yield and this board down here on the bottom, over in the next to Dr. Square, is what he loses each time. That's like waste. So each time he puts up, he has to cut the boards, and this is very common in carpentry. You buy 12-foot lengths, but you really only need 11 feet of it. So your actual yield in this case is what you actually use. Now let's say I go to the gym and I have a cat on a treadmill, and the cat says like, "Hey, I can do an hour and I can do 5 hours on this treadmill." This is your theoretical yield. This analogy is just meant to express like what a theoretical yield is at heart. It's that number 5 hours is kind of gray, even for a cat. But regardless, the cat goes, and how does he do? He does 37 minutes. That's his actual yield. All right. Now let's say I've got a jar of peanut butter. This jar, when you start, is your theoretical yield. All right. How much? That's if I eat all that peanut butter, that's the yield I'll get in theory. However, as you well know, sometimes there's some peanut butter you just don't eat. It's hard to get it all. And what's there at the bottom, everything else was my actual yield. I got all that other peanut butter. Now let's look at a chemical reaction. Let's say I've got a solid and a gas reacting together. You can see the reaction up ahead, and I just noticed something. I just noticed something else. I hadn't balanced the equation. All right, there it is. Now it's balanced. And I have the reactants. I've got some of both, and I seemingly think I've got them equally proportioned because it's all like set. I should be able to make, when I put them in, I should be able to make 4AB. However, as the reaction progresses, I don't make all of it. I only make 2. So in chemistry, your actual yield will always be less than your theoretical yield. There's always impurities. There's always side reactions that kind of happen, or I shouldn't say there's not always side reactions, but there's not everything always reacts. There can be side reactions, like something that's made that you don't intend to. You might not transfer all of your your reactant to your reaction chamber, that kind of thing. All right. Now, let's say I start with 10 grams of each of these gases. This is the rocket fuel I use to get to the space. Here's our our chemical equation that tells us what we're going to make. If you look, now I'm not going to show the stoichiometry here. That's for a different video, but this theoretical yield, you're going to need to do some math to predict and write out and figure out. And so it's 11.5 grams. When I have these two things react, how much do I actually make? Made a mistake. I had grams of H2. This thing should be H2O. That is my my theoretical yield. How much water I make. All right. Now, the actual yield can be different amounts depending upon the reaction. It's not always going to be the same amount. It can really be anything less than your theoretical yield. You might get none. Actually, there be maybe no reaction. Hopefully not. So all of these examples hopefully have showed you that if something that they have in common, all right, in different ways. Not all of them show this, but theoretically, for the last two examples, they come from a chemical reaction that's going to be measured in grams typically, and it's always a product. Your theoretical yield should always be greater than your actual yield. If it isn't, there's a problem. That would mean you're measuring reactants somehow, or you made something you didn't intend to make. Could be two possible reasons that you've got there. I'll repeat them. You made something you didn't intend to make, or you didn't react all your reactant. Now, that says stoichiometry. I didn't show the math, but I will in a different video. And in layman's terms, it's what you should get. It's a maximum, and there's no error in this amount. Whereas the actual yield is what you get. It's based upon lab, and your conditions will affect the amount that you get. Like in the last example, you really can. It's always going to be less than the theoretical yield, and it can vary from experiment to experiment. All right. Here are our sources, and thank you very much. I hope that helps.